Where do ideas for new products come from? When it comes to blue sky thinking, scientists are among the best in the business.
Scientists are brilliant folks. They tend to be very creative. The really good ones are very good at thinking outside the box. And the really good ones are really good at thinking outside the box, not just about their topic, but about the business and about the whole thing that they might do.
But there is a world of difference between dreaming up a nifty idea and actually creating a new product that people will buy. It starts with a novel concept. This was the case for a spin-off company in Cambridge, Massachusetts, called MC10.
The basic history of the electronics industry goes back to the silicon wafer. And most of the processes that we have in place today and have had in place uses the silicon wafer as the basis. And these wafers happen to be thicker than a few microns and as a result, brittle.
Spotting an opportunity, MC10 is developing new, flexible forms of electronics for novel products with health and fitness applications.
The technology has been in the works in Professor John Rogers' lab for over a decade now, and that basic physics slowly transformed into basic building blocks that turned into systems.
It's a direction of research that's really motivated by an observation that all known forms of biology are soft, elastic, and curvilinear, whereas all known forms of electronic technologies are rigid, planar, and brittle.
And so we have partnered with companies like Reebok and others like Medtronic that are companies that are out there developing their own solutions that could benefit from the types of stretchable and flexible electronics that we're developing here. It's really fast-paced. It's really hard to tell where the time goes, but as a lot of the scientists and business folks here will tell you, it's you have to wear a lot of hats.
There was some great relationships between the early founders of the company, always an important thing in young startups. And each of them brought in a really unique ingredient to MC10. So John, clearly the innovation provider in the company. We had an investor who provided capital, really important to scale this type of business. We had a young engineer who was responsible for taking the innovation and starting to translate it into products that are valuable for consumers. And we had a business function that was responsible for framing up the early customer relationships for those products. And those four ingredients were really the necessary inception for MC10 in 2008.
I've met a lot with professors who have a great idea and they want it to happen, but they don't want to do it. And startups don't work without a team. It's not something that you can just give to someone else and say, you guys go run with it. The most successful companies that come out of research centers, some of the researchers come, often it's in a university, it's postdocs or grad students, because professors often don't want to leave their jobs. Sometimes they do, and sometimes they'll take a sabbatical and help get it off the ground. But without some kind of a full-time team, the history of university-based startups certainly is pretty poor.
Just down the road from MC10, at Harvard University, there is another research centre developing novel technologies. Joanna Eisenberg is head of the lab, which is working on exciting new concepts for products inspired by nature.
My general approach, I would call it bio-inspired engineering or bio-inspired materials. It's really learning and then designing something different. So pitcher plant is just one example of that. I don't think that many people knew about this excellent plant. There's this carnivorous plant that doesn't have to do anything to capture food. And the way nature does that, the way pitcher plant does that, it creates extra slippery surface where insects just slide into digestive juices of the organism due to very interesting surface properties.
So what I have here is an omniphobic coating that our lab has developed, and it's inspired by the Nepenthes pitcher plant, and it's called SLIPS. The long form is slippery, liquid, infused, porous surfaces. So you can see here that the oil moves slowly, but it doesn't pin on the surface. So SLIPS has many different applications, and one of the applications we're considering is coating the inside of pipelines with this lubricant layer so that when you transport oil, it'll require a lot less pressure or energy to transport oil through these pipelines.
There is a huge difference between the research, and even if it's applied research, that is done at the university and the products that can be licensed by the companies. There is a range of optimization and development that is not classical of everyday research in the lab. There is a lot of things that I would unlikely give it as a project to my students or to my postdocs. That is more something that should be done either in the startup company or should be developed further by industries that are interested in this technology.
A more difficult thing tends to be is they tend to, the folks that I've worked with have a tendency to be quite over-optimistic in terms of schedules, in terms of what it actually takes to build a real product. They generally haven't built a product. The process of taking something from a really good discovery to a product is a little bit boring. It's very iterative, it's very banal, there's a lot of things that they don't enjoy and then really, really smart people get a little bit bored with. A lot of startup companies end up hitting what we call the valley of death, and that is a situation where you've gotten off the ground, you've built a team, and the results are not yet there in order for you to be commercial. In physics-based startups, that happens very, very frequently because physics is hard and commercializing physics can take a long time. The reason there's a death at the end of valley of death is that if at that point often you need to go raise more money, and if your results aren't there, that can be quite difficult. And there are a lot of dead bones and skeletons at the end of that valley.
All academic startups need to navigate the dreaded valley of death. But for research scientists at the Massachusetts Institute of Technology, they can get some guidance along the way. This comes from the Pandey Center for Technological Innovation.
So the center's mission is really about moving technology from the labs at MIT into the marketplace. So we focus on the commercialization of university technology. There's two major areas. We provide some grant funding, so we're providing some money, small amounts of money, to researchers to really further their research, take it to the point where it can be spun out. So this would be known as translational, possibly proof of concept funding. But we also provide a lot of support services really to try and help them both understand the marketplace, inform what they do in the research. And we have a large group of volunteers who work with the project teams to really move the technology forward. We've been around for about 11 years now, and we've funded about 110 projects. And of those, we've had 28 spin-out companies that have raised around $400 million. One is QD Vision, which does work with quantum dots, and their technology is used in some Sony televisions now to give much better color and also in lighting.
It does help a great deal to be in an extremely supportive environment, one that can provide you both some guidance if you need on how to become an entrepreneur, some guidance if you need to figure out how to actually build a little demo that can be shown to the venture capitalists, how to raise the funds, how to engage the investment community, how to actually build a company by getting your first office outside of the campus.
We have many plans, lots of plans for expansion. Our strategy really is focused on penetrating as much as we possibly can into the TV market with our Color IQ optics. Our goal there is to then look beyond large form factors, so large TVs, and start addressing all-in-one computers, monitors, and then look to notebook displays, tablets.
What is clear from the people appearing in this film is that in business, success requires far more than just a good initial idea. To take a concept from the science lab to the marketplace, spin-off companies must embark on a challenging journey. The ones that succeed have both the stamina and the business sense to emerge from the valley of death into the sunny uplands of commercial success.